Alright, now we're going to look at systems of linear equations and with word problems or contextual, whatever way you want to say it. Alright, steps for setting up application problems. First, you want to define the variables, what does x and y represent, and then you want to write as a systems of equations. So write two equations. Practice setting up systems of equations. You worked 18 hours last week and earned a total of $124 before taxes. Your job as a lifeguard pays $8 per hour, and your job as a cashier pays $6 per hour. How many hours did you work at each job? And notice that I've highlighted the important information. You should do this as well. So X right here, we know that X represents the number of hours spent as a lifeguard, and that Y, we're going to represent it as the number of hours spent as a cashier. Alright, just because it comes first and second. Alright, and so systems of equations that I come up with, I know that I'm going to work 18 hours in that week. And so we know that X represents the number of hours spent as a lifeguard. We're going to say X hours plus number of hours spent as a cashier. That would be Y hours equals 18 total hours. That's our first in our systems of equations. And I also know that I make $8 per every hour spent as a lifeguard. So 8X. And then I also know that I make $6 every hour spent as a cashier, so 6 times Y. Which I also know that I made a total of $124 before taxes. So now I have both of my systems of equations. That's your setup. Alright. So let's look at the next one. A math test is to have 20 questions. The test format uses multiple choice worth 5 points each, and problem solving is worth 6 points each. The test has a total of 100 points. Write a systems to determine how many of each type of question are used. X is the number of multiple choice questions on the test. And then Y is the number of problem solving questions on the test. So we're going to see how many of each type of question are used to make 100 points. So we know that we have a total of 20 questions. And so I'm going to say, okay, well, X is the number of multiple choice, and that Y was the number of problem solving, which that equals a total of 20 questions. And we also know that the multiple choice count 5 points, and we know that the problem solving counts 6 points apiece, which gives us a total of 100 points. So our steps are 4 steps for solving contextual problems. First step is determine the variables, and we notice we did that right here. We said that X is in multiple choice questions and Y was problem solving question. That can be opposite as far as how you set it up, but if you want to keep it just in order, then that's fine too. Write a systems of equations. That's what we did right here. Solve using the best method. State your solution in words. Alright. So here, let's look at this next problem. We got you sell tickets for admission to your school play and collect a total of $104. Alright, admission prices are $6 for adults and $4 for children. You sold 21 tickets. How many adult tickets and how many children's tickets did you sell? So we just kept it in order again. We used X as the number of adult tickets and Y as the number of children tickets. So we're defining our variables right now. This is very important to do. That way you know what you're solving for. You know what X represents. You know what Y represents as far as your situation. Alright, so now we're going to make our systems of equations. we know that the number of adult tickets plus the number of children's tickets equals 21 total tickets. We also know that adult tickets cost $6 and that children's tickets cost $4, which we sold for a total amount of $104. Alright, so right here, I'm going to use elimination to solve this. So I noticed that I have a 4y right here. So I know I have a y up there. So I know that the way I cancel that out is to multiply or distribute a -4 into my first equation. So if I distribute a -4 in there, I'm going to say -4 times x, -4 times y, and -4 times 21, which is going to in turn give me -4x minus 4y equals -84. When you do this, you just got to add them, so I just add them. Alright, so I say 6x minus 4x right here. 6x minus 4x gives me 2x. So if you look right here, you see 6x minus 4x is 2x. And I also know that 4y minus 4y, those are opposites, so they cancel out, they zero out. Just like we looked at before with elimination. And then I know that 104 minus 84 is 20. Okay, so if you look right here, and then I'm going to say I got a one-step equation. So I just divide 2x on both sides, or excuse me, just divide 2 on both sides. And that gives me x equals 10. Alright, so then all I got to do is plug it back into my original equation. And so I chose the first one here. If you see it right here, you can see where I chose the first one. Plugged in 10 for x here. And I get 10 plus y equals 21. I subtract 10 from both sides, and I get 21 minus 10 is 11. So I know that I sold, there were 10 adult tickets and 11 children's tickets to give me $104. I could have also used substitution to solve this. I could have solved my first equation up here for x or y. Either one would have been fine, and just plug it into my other equation. I could have even solved it and graphed it. So there's multiple ways. I want you guys to try the other ones and bring them in tomorrow to show me.